In today's lesson, we're going to talk about identifying some key features of polynomial graphs. So the first thing we're going to talk about is what we call the zeros, or sometimes people call them roots of a polynomial. And the other most well-known name is that it means intercepts. So you have to memorize that if somebody says, tell me the roots or tell me the zeros of a polynomial, that you know that means list the x-intercepts. So on my first example, I give you a picture of a polynomial off to the side, and we want to list the zeros or the roots. So where does it cross the x-axis? So my first point right here is at -1. The second time it crosses the x-axis is at 0. And the third and last time it crosses the x-axis is at +3. Okay, the next key feature we're going to talk about on a graph is what we call end behavior. Okay, and off to the side, we have a little definition. It says end behavior describes what happens to the function graph as your x approaches positive infinity, which is the right side, and as x approaches negative infinity, which is the left side. Now, if you have a picture, you're more than welcome to look at the picture to help you get the answer. If you don't have a picture, then you'll have to kind of look at the chart off to the side here. Okay, so the first thing you would have to do is look at A. And remember, A is the leading coefficient. So that's the coefficient in front of the highest exponent. If A is positive, which means it's greater than 0, you're going to be looking at the top two pictures. If A is a negative number or less than 0, then you're going to be looking at the bottom two pictures. So once you identify A, then what you need to do is you need to look at odd degree or even degree. So we must remember that a degree is the highest exponents. Okay? So degree is highest exponent. So you look at the highest exponent. If it's an odd, then you're looking at the first picture to get your answer. If it's even, you're looking at the second picture. So basically what you're writing for an answer is in behavior. You will always have as x, and we use a little arrow for approaches, positive infinity, and as x approaches negative infinity. So those two parts right there are always going to be set. The part you have to figure out is what does the graph or what does the function do? So we have to figure out f of x, which is what we use for the function, approaches what? Okay, so your answer is either going to be a positive infinity or a negative infinity. So let's say we were having a positive a and our degree is odd. So as x goes to positive infinity is over here on the right side. So if I look at my graph, does everybody agree in this picture? It says my graph is going up. I have a little arrow that's pointing in the upward direction. So that means it is going on forever and ever toward positive infinity because it's going up. Now, as x is approaching negative infinity is on the left side. So if you look at your portion of the graph, you notice that this time your graph is going down. And since your graph is going down, that means that it approaches negative infinity. Okay, so the first example here, I give you the picture of each graph, and I've typed out what X does, and you just need to fill in what does the graph do. So positive infinity, we're over here on the right side. So does everybody notice on the right side that my graph is ending by going down? Put a little arrow here. So that means it's going to negative infinity. On the left side, as x goes to negative infinity, if you look at your graph, it's going upwards. Now I'll put a little green arrow here. And since that's going up, that means it's approaching positive infinity. So on the second one, on the positive side, the arrow is going up, so that means positive infinity. On the left side, the graph is also ending by going up. We have an arrow up, so that's going to positive infinity. So there's your end behaviors when you're looking at a graph. And like I said, if you don't have a graph, then you can go back to the chart and use the chart, or you can graph it with a graphing technology and look at the picture that way. Okay, the next thing we're going to talk about for a key feature is going to be relating back to maximum and minimums, which we did with quadratics, but now with polynomials, there's going to be more than one hump. So that means we're going to have to state the difference between the humps. So we have what is called a relative and an absolute min or max. Okay, to be an absolute max, that has to be the highest hump that the graph will go. It has to be the highest point that the entire graph will go. So if you look at my picture off to the side, you're going to notice here we have two humps that are max. So I'm kind of outlining them here in green. And then you'll notice that the top one goes higher up than the bottom one. So that's why it's called an absolute max. And the other one is called a relative max. Now, the low humps, we only have one of those right here. So that's a minimum. Now, how do you know if it's a minimum relative or a minimum absolute? Well, do you see that there are arrows on the end of my graph, which means those lines go on forever and ever? So those lines will always be going farther down than our hump. So that means the hump is not the lowest point of the graph because the graph continues on. So that's how we get it to be a relative and not an absolute. Now, along with identifying absolute or relative min or max, we also want you to list the ordered pair. So when we look at example number 3, okay, you've got 3 humps here. So I'm going to outline each one here. So if I look at the first one, this is what I'm going to call the first hump down here, and then this will be my second one, and this will be my third one. Okay, so my first hump, I decide, is it a min or max? And if it's a low point, is everybody okay with calling it a min? So look back up at the picture. They call the low point a min. Now, is it relative or is it absolute? This is the lowest point for the entire graph, so that makes it an absolute minimum. Now, list the ordered pair for that point. So that looks like -2, -4. Okay, if we go to the second point, that one is a top hump, and a top hump is a maximum. Now, to tell if it's min or relative or absolute, you have to think, is that the highest that the entire graph goes? And no, because you'll notice that these lines right here go above that hump. So it's not an absolute, it is a relative. And then if I list the ordered pair for that, we're looking at 2, 0. The last one, this is a low hump. So once again, a low hump is a minimum. Is it an absolute or a relative? Well, it can't be an absolute because we've already named that. It's not as low as the other one. So this one has to be a relative. And then list the ordered pair for that one. And it looks like we got 4, -1. Okay, let's go over to the next picture. In this picture, it looks like I have 4 humps. So I'm going to start with this one in red. Okay, that one is a low hump, which makes it a min. It is not the lowest that the graph goes because do you notice over here to the side that we have an arrow pointing down, which means that line goes farther down. So this is a relative. And then we have the ordered pair given to us, -17, -10. Okay, and then I'm just going to stick with mins again. So does everybody notice I have another low point right here that I outlined in red as well? And once again, that is not the lowest that the graph goes. So that is also a relative min. So I have 2 relative mins, and they are at -17, -10, and 7, -2. So it's perfectly fine to have more than one relative min, but you shouldn't have more than one absolute min. Okay, on the other 2 humps, they are both at the top, so that's going to make them maximums. And there's no portion of the line that goes on forever and ever, so that means one of them is going to be absolute. So which one goes up the highest? Well, hopefully everybody says the absolute max would be at 0, 11. Because that one goes up 11 where the other one only goes up 9. So, and therefore my relative max is the other hump, which is 13, 9. So now what we're going to do is we're going to take this last question here and we're going to put all the different key features we talked about together. Okay. Now, if you have a graphing calculator at home, feel free to use your graphing calculator. If not, we're going to go out on the internet and use a site to help us. So I go over here to Google and I type in Desmos graphing calculator. And then the very first one pops up for graphing calculator Desmos. So I'm going to click on that. And then over here on the left side, I'm going to type in y equals. So don't use f of x. I mean, you can use f of x. I just think y is easier. It takes less time to type in. And then x. And then to get your exponent, hit shift and 6. And that puts an exponent. Type in 4. Arrow down. And then plus 2x. And then shift 6 to get exponent again. 3. Arrow down. Minus 13x. Shift 6. 2 for my exponent. Arrow down. Minus 14x. Plus 24. Okay, touchscreen. Your Chromebook is a touchscreen. So I'm going to touch my screen and I'm going to change it to where I can see more of my picture. However you want to change it in and out. I mean, there's lots of different ways you could do it. Okay. But if you look at this, hopefully you're going to notice that after you type it in, it kind of looks like a W shape. Okay, so hopefully everybody has a W shape. Okay, so the first thing it asked for was zeros. So if you look for where it crosses the x-axis, so if I start on the farthest left, when I touch that, does everybody have the ordered pair -4, 0 show up? So that means one of my roots is at -4. Go to the next one, which is -2, 0. So -2. Then we're over at 1, 0, which is 1. And the last x-intercept is at 3, 0. So now in behavior. So if I look at the graph, on the left side, does everybody notice that my graph is going up? It's going upwards. So as x approaches negative infinity, f of x approaches positive infinity. So now if I go back and I look at my picture on the right side, my graph is also going up. And since my graph is going up, that means it's going to positive infinity. Or if you wanted to do this without the picture, okay, leading coefficient. So what's in front of x to the 4th? Well, that would be a 1. So is everybody okay with saying A is positive? The degree is the highest exponent, and the highest exponent in the problem is 4, which 4 is a even number. So if I go back here to my chart, I got a positive A, and I got an even degree. So you'll notice right here, it tells you each function, whether you're on the left side or the right side, should be approaching positive infinity. So now back to the picture. The last thing we have to do are the min and maxes. Okay. So if I start with the bottom humps, these two humps right here are both at the same spot. So since they're tied, they're not considered an absolute. They're considered a relative. Okay. So I'm going to go back here and I'm going to say we have a relative min. And then I'm going to take the ordered pairs they give me, and I'm going to round to the tenths. So instead of rounding out several places like they do, I'm just going to round it to the tenths. So the first one is -3.2, -25. And the second one is 2.2, -25. Now, I'm so sorry you can hear my puppy barking. The last hump is the one at the top. This one is not an absolute either because you have the two lines that are going up past this one. So this is going to be a relative. So once again, we have a relative max. And then on my ordered pair, I'm going to do -0.5. And then I'm going to round the other one to 27.6. And that's it. Thanks.